alaikum wa rahmatullahi wa barakatuh. So you are welcome to another edition of our online class. So we are still on logical reasoning, and today we'll be discussing validity of arguments. When do we say an argument is valid or invalid? So, and you remember that on the first day I told you that we have two types of logic. When you hear logic, that is scientific reasoning. So I may be using logic, I may be using reasoning. So we have deductive, and as you can see it on the board. So when we are talking of deductive reasoning, we are talking of a statement or a reasoning that their premises warrant their conclusion. So we are saying that this deductive argument is when you are moving from a general statement to a particular statement. That is, you are moving from a general attribute that you know that this attribute is something that is common, that is for a particular group of maybe insect or something like that. So a character or features that is common to something, you are now moving from that general features, you now want to specialize that features on a particular individual. So look at it now. We say that this statement is from a general statement to a particular instance of statement, which we also say it is from general to specific. Like this one now, we say that you see that all meters conduct electricity. You see that is a general features of meters. So because meter can be iron, something like that, sodium and so on, and they say that all meters conduct electricity. That is what this one is what we call the general. You see that this is general. So now this second premises now is now telling you the property of a copper also, that copper is what is a meter. Now using that general property of what we know from meters, we now want to specify that property on what, on copper. That is, this one is what is general statement. This is general statement that all meters conduct electricity. Then from here we know that copper is a meter. Then if copper is a meter, which means that therefore copper will conduct electricity. So this is what we call general statement, or you see general truth. Then this one is what we call what? We have specified the features here. So this is what we call specific statement. Because here is telling you that meter is what conduct electricity. Although we might not even test for property of meter whether it conduct electricity or not, but we assume that since the statement here, the general statement is that all metals conduct electricity, and we know that copper is a meter, so we now even test whether copper conduct electricity or not. From the general statement above, we now conclude, our conclusion is now that meter also conducts electricity, and which is true. This thing can only be false only if one of these two is false. But let's say the statement here, all meters conduct electricity is set so or some meters, but this thing, it does not exclude any meters. Once this statement is true and once this one is also true, that copper is a meter, then this one is what? So which means we can specify that meter is also conducts electricity. We can still have another example on that. So for example now, let's say this one is example 1. Then also number 2, we say all humans are mortal. So that is one statement. The second statement is now that Nigerians are mortal. So definitely from there we can say that Nigerians are human. So therefore it means Nigerians are human. Nigerians are human. Now, all humans are what? Are mortal. That's general features of for humans. And this one is now painting a view of Nigerians, that the Nigerians are also what? Are also mortal. So definitely if Nigerians are mortal, it means that Nigerians are what? Are human. It can also go this way, that you can say Nigerians are human, then the general statement will be therefore if Nigerians are human, then Nigerians are mortal. So it can go in any of the direction. That is that of deductive reasoning. And this deductive reasoning is very, very important in mathematics. Most of the theorems or all the formulas you see, they are discovered in mathematics. They are discovered using inductive reasoning. But when they want to prove all these geometrical or all these geometric proving, so there is no way they use deductive reasoning to prove all those relations you see in mathematics, although most of them were discovered using inductive reasoning, but when they are going to prove it, they make use of deductive reasoning. Now we are now moving on to inductive reasoning. Inductive reasoning is something we say it lacks this one lacks generality. So this one moves from a particular instance or statement to a general statement. The reason why we say it lacks generality is most of the time this inductive reasoning we find it to be invalid. Are you getting it now? So in argument logic, you don't say something is correct or not correct. You say either it is valid or invalid. Now this inductive reasoning is like all the examples here, which is from general to specific. When you now rearrange it, it will be from specific to general. So most of the time, that's why we see most of the time inductive reasoning are not always valid. For example, now the example we use here from general to specific. Remember this one, this is general, and this is what? Specific. This specific. Now, from the example we have here, look at this place. See, copper is a metal. Copper conducts electricity. You see how this one they are specific statement. So let us say we now want to move from this specific to general to be an example of our inductive reasoning. Let's say we say copper conducts electricity. Copper is a metal. Now I say therefore all metals conduct electricity. Now that is an example of what? Of inductive reasoning. You see, in deductive we move from general to specific, but here we now move from what? From specific to general. So this property is to copper only. That is specific property, that copper conducts electricity, right? And we know that copper is a metal. Because copper now conducts electricity and copper is a metal, we now make our general conclusion. This one is no more a specific conclusion. So because of property of one element, metal, that we know, because of that one property, we now generalize the property for what? For all the metals. So you know this one when you look at it you see that it is true, right? So this one is from specific, and this one is what is general. When you do this you see that this one is invalid, but sometimes it might not be valid because it's like you are doing from a larger population. It's like you are selecting some samples which cannot be 100% true. The reason why we say in logic we don't say that something is correct or incorrect is because there is no way it can be 0% false and it can be 100% true. So it's only deductive logic that we used to see in case of 100%, but in inductive we assume that you are just basing your judgment on small sample out of the larger population. Do you get it now? So because of just one property of copper which we know to be meter, that we know, we now assume that all meters conduct electricity. So you see that an assumption is not something we can say is 100% correct, because we cannot just say because out of over 1 something element that we have and we know the number of meters we have there, we now say just because of just one party of copper we now make our general features on meter. Now that is that on the inductive reasoning, and I told you earlier that this inductive reasoning is what they use to discover some relation in mathematics, but when they want to prove them they make use of deductive reasoning, and some of analogies that they use in mathematics is with the help of this deductive logic. Now how do we now determine whether an argument is valid or invalid? So that is what we are moving on next. So we now see validity of argument using what? Using truth table. Validity of argument using truth table. Using of truth table to determine arguments. So let's start from example 1. Using truth table to determine following. One, example 1. So example 2. Maths or art. That's the first premises. Second premises, the teacher is not teaching. The teacher is not teaching maths. It's not teaching maths. So if the teacher is not teaching maths, therefore, comma, the teacher is teaching art. Now, let's determine the validity of these two examples. So of these two examples, let's call this one A. Let me call this one A. I call this one B. Now, solution now. So the first question. When you look at the question for A, so the first statement or the statement. The first one says, if I love my wife, if I love my wife, that's the first statement. So the second statement is that I love my wife. I love my wife. Then the conclusion, this is the conclusion. The conclusion is that therefore I will buy her what? I will buy her a gift. So that's the conclusion. I will buy her a gift. Now, when you look at the statement, you just have like something. Let's say P. Let P equals what? So I love my wife. That is P. That is P is I love my wife. I love my wife. That is P. Then let Q be what? I will buy her a gift. Q equals I will buy her a what? Buy her a gift. Buy her a gift. Now, which means that the first statement here that says if I love my wife I will buy her a gift. So this one is what? When you look at this, you see that the stand for P implies Q. Are you getting it now? So look at it. If I love my wife I will buy her a gift. That is what? Conditional statement. That is, which means that this statement is that P implies Q. That's the meaning of it. Then the second statement says I love my wife, and we have this one is now what? It's now P. So that is it. This one is P. Are you getting it now? So this one is P implies Q. This one is P. So which means that the conjunctional statement, the combination of these statements must what? Must give us the conclusion. And the conclusion is that therefore I will buy what? I will buy here a gift. Then what is I will buy a gift here? Which is Q. Which means the conclusion is what? Is Q. That's the meaning of this. So this one is this. Now, when we now look at it, is from the first statement, which now states that if I love my wife, I will buy her a gift, which means we now have P. This is what we'll be looking for. P, implication of Q, then intersection, that is cap, P, then everything must give us this. That's what we are trying to say. So when you look at it now, look at the thing together. This one stands for if I love my wife, I will buy her a gift, and I love my wife, then I will do what? I will buy her a gift. I think you are getting it now. So this one is what? If I love my wife, I'm doing this so that it will be clear to you because I don't have that time. If I love my wife, I will what? I will buy her gift. That's it. So this one is that says that I love my wife. I love my wife. Are you getting it now? And this one, that's the what? Conclusion. This one is conclusion. Conclusion. That is, I do what? I will buy her a gift. I will buy her a gift. So if this thing, we now want to use truth table, whether this statement, this argument is valid or invalid. How do we do that? So now we now want to test whether these arguments are valid using truth table. So we now say we have P here, we have Q. So after that we have P implies Q. Then after that we have P implies Q. Then intersection, that is cap P. So that is what we are going to test now. So here we have true, false, true, false. We have false, true, then false, false. So implies means we have true here. This one, the consequence is false, which means this one will be false also, then this one is true, right? Then this one is true. That is, this one means that if I don't love my wife, I will not buy her a gift. So you now want to, this one now means this is cap this one, that is this one conjunction with this. So which means we now have true, this one is true, right? So when we look at this, we have this one, we have false, then we have true, this one will be false, then we have this, we have true, then we have false, this will be false, then this one we have false, so that's false. Is that correct? Then after that, you see it now still remains this. It now remains the last column, which is P of this. P, everything implies what? It implies Q, right? Everything implies Q. That's the last column. So which means you want to compare this, right? You want to compare this and this. That's the name of it. So when we start, it now means that true here implication of this, so which means we have true. Then here we have false, that if this one is not happen, this one is not happen, which is true, right? Then after that, the same thing means for this. So this one is also true. Why? Because for the implication, this thing is only false. We can only have false for the sign, implication sign, only when consequence alone is false. So which means here our Q is the consequence here now. So here we have false, we have true. So which means this one is true. Here we have false, we also have false. Since it is true false, which means if one is not happening, the other is not happening too. So which means we have true. And I told one that earlier that when you do your truth table and all the columns are true, that is what we call tautology. So for this one now, we can say that this one is, because it is tautology, you can say it is 100% what valid. So now this says P implication Q copy, then this is tautology. So the meaning of tautology, i.e. all true. Some of you, I don't know your program. Is tautology, hence the statement is what is valid. The statements or reasoning is what is valid. So here tautology means all are true. For the entire column. So that is that. Then the second sample. The second example. So I think this one is clear. Now, so now move on to the example, the number B. So after this example, I will just write your assignment. So the question B, remember the first premises is that that premise is what we call statement. You know that. So the first premises is that the teacher is teaching math or art. The teacher is teaching math. So the teacher is teaching math. Or art. So second premise says that the teacher is not teaching math. The teacher is not teaching math. What do you think the teacher is teaching? If he is not teaching math, is he teaching logic or what? So the second semester says that the teacher is not teaching math. Then what's the conclusion? So the conclusion is that if the teacher is not teaching math, then therefore the teacher is teaching what? Is teaching art. Teacher is teaching art. teacher is teaching art. So that is that. That is B. Now, what are we going to do now? We will now select let P be that the teacher is teaching maths. Are you guessing now? P is the teacher is teaching maths. The teacher is teaching maths. Is teaching maths. That is for P. Then let our Q be that. So it's only P that we have there. Let our Q be that the teacher is teaching art. So Q be that the teacher is teaching art. Is teaching art. Are you getting now? Then this one says that the teacher is not teaching math, which means that since P is the teacher is teaching math, then negation of P will be that the teacher is not teaching math. Are you getting it? So which means negation P equals the teacher is not teaching what? Is not teaching math. Is not teaching math. Are you getting it now? So which means that what are we going to be checking out? We combine all the three premises, that's the three statements, the arguments together. If you look at the first one that says the teacher is teaching math or what? Or art, and we say that our P is that teacher is teaching math and Q is the teacher is teaching art. So which means this one is telling us P. You know when you have or, when you see or means what? Or means this, have it? So when you see or, you see or is this, it means this, that meaning of or. So which means the teacher is teaching math or art means this. Are you getting it now? That is the meaning of it. Are you getting it? So because of the or that we see here, it means the teacher is teaching math or art. You represent that one with this. Then the second thing is we say the teacher is not teaching math. That is what we call our negation of P. Are you getting this? Then conclusion, therefore the teacher is teaching what? Is teaching art. If he's not teaching math, it means he's teaching art. So which means this one is what? We call this one Q, because Q says that the teacher is teaching art. So which means the conclusion of the statement is what? Is this Q. So what are we going to check now? It means we will now check for so we now check for, so what we are going to test for is this. We are going to test for this. So P Q, right? Then intersection of negation P, everything to give us this must implies Q. Everything must implies Q. So that is that. That is what we will be checking out. So let's use this place. Let's use this place. Come on, as well. So I think you got it. And I think you have beaten this one before. Which means we now have P, we have Q. So what do we have after that? We have negation P. We have negation P is there, negation P is there. So we have negation P. After that one we have, then we now have P. That's what we will be looking for. We have this. After that, what next? We have P. the intersection of curve of this. I think that's that. Then after that, because I don't have a space, can I use this? Let me use one juju for you. You can put your Q here. Are you getting it? You know Q is here already. You can still put it here so that I want to do something because I don't have enough this thing. So I can just do this. You know Q is here. So I can put that implication sign here. You get it now? So the entire of this, it means the entire of this, then implication sign, so that if I put my Q here, I can just trace this one down. Are you getting it? Now, I do it like this because there is no enough space. Do you get it now? But it will still be the same thing. Now, we have true, false. Yes. Then negation of P means what? This one will be false. This one also false. Then we have true. Then P call Q. So if any one of them is true, we have true, have it? So this means we have a true, we have a true, we have false. Right? Then we have this, cap this. So which means here we have false. So we have false, we have true, we have false. Then my Q, I want to write my Q here, which is true. My Q, I want to just bring it in. We have false. Then we have true, we have false. So the pencil is now between this one and this one, right? So which means we now have this one and this. You know, this now our consequence, this is the antecedent. So which means this one is, since the consequence is true, it's also true. Here consequence is false, but this antecedent is also false. Which means this one is not happen, this one is not happen. So we have true. Then here we have true also. Also we have true. So which means the argument is also what? Is also valid because we have tautology, right? So therefore the argument is valid. The argument is valid. So that is what. So this result is what? This column is what? Tautology. But the question now is it necessary that before this thing must be valid, that the column must be tautology? Is not necessary. But the reason why I don't bother myself to check that one is because when I also have I already have tautology. But there is another way of checking it, and the way is that if your first premises, you look for the column where your first premises is true, the second premise is true. Are you getting it now? Then trace it to the final thing you get. If it is also true there, it means that the argument is also valid. For example, now this is what I'm saying now. You see this, I don't need it. You see I have a P called Q. You see, like this place now where I have P called Q. You see I have true here. Are you getting it? That's my first this thing. So which means that then the second premise also there, I have this one to be what? To be true. But you see that this one is true here, but this one is false here. I don't need to consider that. You now come to this place. This one is the first premise there is true here, and this one also here is what? Is also true. Because you see, it's like we are moving. Let me show you. So, you know, the thing is very simple. It's like this, your first premises, that what? That the teacher is teaching, or I've written it up. And it is your first premise. Your first premise. and this one is your second premise, social. Then this is your conclusion, conclusion. So which means that every place where this thing is true, if this one is true and the entire of this thing is true and this one is also true, it means the argument is valid. This is what I'm saying. When you come here, you see that this place, this one is true, and you still come here, you see that it's also true here. So you trace it here. Now the complete of this one is also true. So which means this one alone is enough for you to say that the argument is valid. Are you getting this now? So I think because of our time, let me give you this. Let me just give you this so that you can do it. So do it as an assignment, and you submit it to the assignment platform, the portal. So let me give you the assignment. The assignment is this. Copy and complete this table. Copy and complete. Assignment. So copy and complete the table. Where is the table? I'm coming. I will show you the table now. So we have this. You copy and complete it. So I have true, false, true, then false. So we have, I want you to do this. Check Q. Then P implies Q. That's what we are going to do. I also have minus P implies is negation, is not minus. So do negation, P implies negation Q. Then the last one is negation Q. You see, this is the biconditional. I don't want to hear, I don't see it, so let me write this for you clearly. But I don't want that to be an excuse. So you should do this. So that is what? Biconditional statement. So you fill the table, complete the table. You know this kind of thing, I'm very sure almost 80% of you cannot type this one. And if you use for your phone to type, some sign like this or may not display using WPS that you used to type on your phone. So I will advise you that you just do the solution in a sheet of paper, you snap it, then go to the attachment section of the assignment portal, you add it as the attachment. Just comment at the written spot that you have attached the thing. Then number two. So this one is number one. So number two. The number two is this. It's just a normal statement. So I want you to just interpret it. That you say determine the truth and value of the following. Determine the truth and value of the following. I know you can do it. Speak of the following. And also represent them with what? With a symbol. Abuja is the federal capital of Nigeria, and Lagos is the largest commercial city, and Lagos is the largest commercial city in Nigeria. Is that true? So B, triangle have 3 sides implies that the triangle is a polygon. So I don't want that. So 12 is an even number, or so 12 is an even number, or 12 is an even number, or minus 5 plus 3, or minus 5 plus 3 is greater than minus 2 plus 5, minus 2 plus 5. So should I make it 3 for you? Or C, a pentagon. C, a pentagon has 5 sides, or 109 is a prime number, or 109 is a prime number. It's a prime number. I think that is that. Let me show it down. So I think you can see it clearly. So that's the assignment for you. So it's something you submit into the portal.